Yeah, welcome to the structural analysis 2 video lecture. So in this, regarding fifth unit, that is moving loads and influence lines. So let's have a small interaction on the basics of moving loads and influence lines. So coming to the definition of an influence line, this represents the variation of the reaction, shear, bending moment or deflection at a specific point in a member as a unit concentrated load moves over the member. So moving loads, in the name itself we have that the loads will move from one end to the other end or from one section to the another section. Say a load may be a point load, or it may be a UDL, or it may be a UVL, or any other type of load. So if we find the reaction or draw the shear force diagram or the bending moment diagram, or if you find the deflection at any point, the diagram which represents all these parameters, that means only the reaction or the shear or the bending moment or the deflection at different points, and if we join all these points together, that forms a line, and that is called as an influence line diagram. Like how we draw a shear force diagram and bending moment diagram and also a deflected shape for any type of beam or a portal frame, in the same manner for that parameters we draw an influence line diagram. For that, a unit concentrated load that moves over the member can be treated as a moving load. So how the construction of influence lines is taken? An influence line can be constructed at a specific point P in a member for any parameter. Like just now I had told regarding that, this is the same point, reaction, shear or moment. Next point, when the applied load is not fixed, we use influence line to determine the impact of live moving loads at a single point as the load moves across the beam. Influence lines are important in the design of structures that resist live moving loads. So in the design of a building, which comes in the design of reinforced concrete structures, only for dead loads it is designed. So what about the live loads which are moving on the structure like a beam or slab, whatever? So influence line diagram plays a major role in that. So the construction of influence lines is much important for determining or for designing the structures which resist live moving loads. Next, these represents the effect of a moving load only at a specified point on a member. Only at a specified point, the effect of the reaction and the effect of the shear force and the effect of bending moment is determined by using influence line diagram. Whereas for shear force diagram and bending moment diagram, this represents the effect of fixed loads at all points along the axis of the member. So these are influence line diagram which represents only moving load, whereas shear force and bending moment diagram, those represents the effect of the fixed loads that is happening on a beam or any structure. So this can be treated as a small introduction part of the influence line diagram and moving loads. And when coming to a small numerical problem, Construct the influence line for the vertical reaction at A of the beam for a moving load of 1 kilonewton. So when you look after this, so here we have to draw an influence line for the vertical reaction at A. So if there is a moving load from one here and it moves along this like this as shown in the video. So it moves at a distance x, and this is the simply supported beam, and this is reaction RA and RB, and summation of MA is equal to 0 if 1 kilonewton load is acting at A and it is moving along this until B. So if it is stable here, suppose let's stop the load here at some distance x, and if we find the reactions RA and RB, so from the simple equations of equilibrium, we know that RA plus RB is equal to 1 and summation of MA is equal to 0. We get 1 into x minus RB into total distance as L, and this is, then we get RB as x by L, and if we substitute RB in this place, we get RA is equal to 1 minus x by L. This is how it is done. Next. So now going to case 1, at x is equal to 0, at x is equal to 0, that means that is for reaction RA. For reaction RA, we have RA as L minus x by L, already it is shown here, and at x is equal to 0, RA will be 1. That means that load is at 0. Okay, x is at 0, that means that unit load is exactly at point A, and at x is equal to L, RA will be 0. You must observe only the values of RA when x is equal to 0 and RA when x is equal to L. What does this x represent? That x represents the position of the unit load. That means if it is 0, that x is at, where the load is at A, and if this is L, the load is at B. So if you generally think that at B, okay, we have here at B, what does this RA does? This RA doesn't have any kind of its magnitude or reaction at B. That means it doesn't have any power at B. RA reaction A doesn't have any power at B. Only it can show its power only at A up to full-fledged power at A, and accordingly as the length increases at B, the power or the resistance force, what we call generally in structural analysis, that will be reduced as we come across B. So that is what it is drawn in the diagram. So now if we draw a diagram like this by using the moving load 1 kilonewton, we have found a reaction RA, that is L minus x by L. For drawing ILD for reaction RA, we have substituted x is equal to 0 here and x is equal to L from A. And using that values 1 and 0, we have drawn a diagram like a bending moment diagram, which is influence line diagram, but both are different. So this is the diagram that represents the influence of the reaction RA over the entire beam when the load is moving from A to B. Next, this is for case 2. In the same manner, we have RB is equal to x by L, and at x is equal to L, RB is equal to 1, and at x is equal to 0, RB is equal to 0. So if you substitute these values in the reaction RB, we get these values. So this is how an influence line diagram for RB is drawn, like this. Okay, in this manner it is drawn. Next, influence line diagram for shear force. So about this, it will be discussed in the next video. Thank you.